All right, kids, this is the final exam review. So I'm just going to throw down some notes here about what the exam looks like and whatnot. And this is what I'm basically going to tell you tomorrow, but in case you're wondering. All right, so I looked through the exam. I tried to tally some stuff. So this isn't awfully accurate, but it's somewhat accurate. Stoichiometry, you got about 12. Should I write that down? There's about 12 questions. Heat, you got about 9. Reactions, balancing, we have a fair number, and that's because 19. And that's because that includes like collision theory and enzymes and stuff I kind of threw in there with reactions. So make sure you know why reactions occur and what concentration does and all that kind of stuff. Solutions, 15 questions. Bonding, so ionic, covalent, molecules versus formula units, all that kind of stuff, 16. Acids and sort of some unit X with equilibrium and whatnot, 12. And then gases is a low 9. Low 9 on gases. So that's that. As for equations you need that are not included, I took the test myself, and I did not have MAVA equals MBVB. That was not provided, and I needed to use that. I needed to use PV equals nRT, and that was not provided. The R's are all provided, but not the equation. And I also used PV, P1V1 over T1 equals P2V2 over T2. And again, that equation was not provided. Other than that, all the provided equations were there, such as joules equals mass times specific heat times the change in temperature. But that's how it's given. Right? Joules equals delta H times mass. But that's how it's given. So I'll give you all your constants. You don't need to know any of those. So, yes, I hope that makes sense. And yeah, so a fair amount of stoichiometry. The thing to remember, though, is every question's worth a point. So if there's a bear of a question, and there's a few out there, there's about 3 that take much too much time. And if you don't want to invest that time or energy into it, then just guess and move on. It's worth 1 point. It's worth 1/95th, not even 1/100th of your test. So I wouldn't worry about that. All right. So the other thing that we were talking about is the short answer, and let me just make sure we have this covered. So the first short answer is mathy. So we're talking about stoich, and you get to choose one of these: stoichiometry, limiting, reactants, that kind of thing. So you're going to use math, factor label stuff to figure that out. Dimensional analysis, as it were. 2, as we talked about, with solutions, you're talking about what is saturation, concentrated, what dilutes things, what happens when you put salt in water as far as freezing and boiling, those type of things. Question number 3 has to do with titrations, and you only have to answer one of these, right? Why we did it, what's the point, that kind of stuff. Question number 4 will deal with so this idea where you map something out. So for example, the example given there, let me see if I can think of something better from last. So if we were going to talk about ionization energy. So ionization energy. So number 4 would have a few words of definitions. Ionization energy was last semester, so it won't be on this test. First thing I would want is your definition in your terms. So you would say the energy to pull an electron away. To pull an electron away. That's hopefully your words, away from an atom. All right, so I'm going to be concerned if you quote Wikipedia on that. That's going to be my concern, but not terribly. Well, I'm going to be concerned. Okay, and then you want to illustrate it. So you can have, for example, a potassium atom, which has 1 valence electron flying around, and then you can draw like a guy trying to steal it. I'm going to go with the Hamburglar. Is that still a thing? Try to draw a little Hamburglar here, right? So here's the Hamburglar, and he used to wear a striped outfit, and he is stealing the electron. Do the stripes on those go up? I mean, I guess, I don't know why I made his hand go out that way, but here, he has a sack of electrons. Look, that's why I made his hand go out that way. All right, so there's the, maybe give him a mustache. All right, so he's trying to steal that electron. And that's what it is. And it takes energy. Or not. But anyway, there it is, an illustration. Very nice. That's what I'm looking for. There will be 5 terms there. They're going to change, so don't talk to people because they'll be different. That is what question 4 will be. So I'm just looking for a definition in your own words and then some kind of picture, illustration, whatnot. You can write. You don't have to draw a picture. Like I said, I've done Kardashians and whatnot. If you want to just use words, like it's like this movie where this guy did this, that's fine. I'll go look up that movie. All right, number 5. I think I've run out of things, so let's do that. So from current side, so number 5 is going to be the heat temperature stuff. You know, why? A lot of whys in this section. Be sure you can answer why. And then number 6 is sort of reactions in gas, like I said. I'm going to try to relate them. Some tests might just have something about gas. Some tests might just have something about reactions. But when I say reactions, I'm talking collision theory, right? Why surface area and concentration and heating up and all that stuff have something to do with it. And with gas, we're talking about PV equals nRT type relationships, more relationships than math, right? Pressure goes up, volume has to go down because they equal this constant and all that kind of stuff. All right, so that is a pretty good review. That's what I'm hoping to say tomorrow. I'm assuming some people will miss it. Some people will be doing other things like their tests. So now you don't have to worry about what I said because it's all on video. All right, so best of luck, kids.